Continuing Saxon's Trig Lesson 6. This is Section C, Systems of Three Linear Equations. This is a much more complex because it has more pieces. So it gives me three initial equations. Whoops, plus the z, sorry about that, equals 16, and the final one, x minus 2y equals 0. I need to do and this was originally given, so I know that in my final answer, that doesn't continue or just goes to a peak. In my final answer, I will end up with 3 coordinate point because it's got x's, y's, and z. So it will be x, comma, y, comma, z for that answer that I'm going to box. So I have 3 equations, 3 unknowns. It is solvable, and I need to figure out whether I'm going to substitute or eliminate. There are multiple ways to do this problem, not one set specific way. So if you see a different set of equations than I have seen, that still works and is okay. I see these two, and I can look to see, can I easily eliminate something? Sure. The z's would immediately cancel themselves off and leave me with an x and a y. And that would balance with this x and y. That is an easy then solution. I could choose to solve for this x because this is a 0, so that's also easy, and everywhere there was an x, I can plug in a 2y, and then I would still have to, I would then have y and z together and could eliminate the z's. So again, whichever way you choose to do it is perfectly acceptable. I'm going to do this addition of these two first and eliminate those z's. So when I do that, 2x plus 3x is 5x, 2 plus 3 is 5y, z's have canceled off, and 16 plus 14 is 30. Then I have the x minus 2y equals 0. You know what? I said I could eliminate here, and I can, but that's actually not quite as easy as doing the substitution. So I am going to choose to solve for x, add it over, and get 2y. Now, because the concept for x is 2y, I'm going to plug in where the x was, the 2y. So that gives me 5, 2y instead of x, plus 5y equals 30. So 10y plus 5y equals 30. 15y equals 30, divide y equals 2. I have my first answer that I can plug in up here. Go ahead and do the parenthesis. Now, the easiest place to plug that is where I just had an x with that y alone, so that's a simple place to throw it. So we're going to have x minus 2. Instead of the y, write the 2 equals 0. So x minus 4 equals 0. Move the 4 over, x equals positive 4. I can fill that one in. And now I have the 2. I can go back to one of the original ones and get the z. Numbers were about the same, but this one's a little smaller than 16. I'm just going to do it. You can plug it into the other. It really doesn't matter. So 2 times 4 plus 2 times 2 minus the z equals 14. So we have 8 plus 4 minus z equals 14. 12 minus z equals 14. Move the 12, negative z equals 2. And then when I get to here, I don't have a number that I see, it's an implied 1. So I can choose to say negative 1 needs to be divided out, or I can just say I need this to be positive, which means everybody's sign has to change. Either way you think your way through it, this becomes negative 2 filled in for the final answer. On page 52 is the next example 6. X plus 2y plus z equals 4. 2x minus y minus z equals 0. And 2x minus 2y plus z equals 1. So I again begin my thought process of planning out what do we eliminate or substitute. If I put these top two equations together, those z's will cancel, and I would have an x and a y combination. That does not help me with the third one because it's not just straight x, y. Anything that I would solve for, an x or a z, is going to give me two other letters, so a substitution is probably not my best bet. I'm going to assume then that what I need to do is try to eliminate these z's in the first two equations. That would leave me an x and a y combination. Can I do the same with another two equations, the bottom two or the top and bottom that I have not used? Either way, yes, I can. I'm going to look at these bottom two because they would immediately eliminate the z as well, leaving an x and y combination. That's good. If I put these two together, I am not immediately eliminating the z. I would have to go through changing the sign step, and I'd like to avoid extra steps. So let's put these top two together and add them and get an xy equation. So 1 plus 2 is 3x, 2 minus 1 is 1, or just write it as y. Either way, z's have canceled off. 4 plus 0 is 4. Now do the bottom two together. 2 plus 2 is 4x. Negative 1 and negative 2, negative 3y. Z's are canceling off. 0 plus 1 is 1. Now I can take a look and see, substitute. Well, I could solve for this y and substitute in, or I can go for an elimination. Since I did a substitution last time, I'll go ahead and do an elimination this time. So I'm choosing to eliminate the y's. This one has a negative 3. I want this one then to have a positive 3. So I'm going to multiply this entire equation by 3 in order to make them match up. So 3 times 3 is 9x. Positive 3y equals 12. Now when I add these two equations together, the y's eliminate off. This is 13x equals 13. X equals 1 when I divide. I could have gone ahead and done my 3 places because I knew I had them. So x is the 1. Now let's plug back into one of these where they were shorter, and I just have the y. So let's go with this top one. It doesn't really matter. 3 times 1 is basically 3 plus y equals 4. So y equals, subtract that, get a 1. X, Y, Z. I still need to get the Z, which requires me to go back to one of the originals. Since this one equals 0, it feels like it's simple, so I'm going to do it. 2 times 1 is 2, minus 1, filled in, minus Z equals 0. So 2 minus 1 is 1, minus Z equals 0. Move the 1 over, which minuses it, turning it to negative 1. And then we again either change the sign or divide by negative 1. Z is 1. So this one happens to have all three of the numbers be identical.